We are at question 82 in our guided notes, which is on the next key concept number 7. So copy this down in your notes. Different types of light have different wavelengths. So pause and write this. Okay, so the thing that makes different light different from each other is the wavelength. Colors like red have long wavelengths. As you go down the rainbow, orange, yellow, green, blue, indigo, violet, the wavelengths get smaller and smaller. Once you hit violet, if you go even smaller, you get to ultraviolet. You can't see that, but it's smaller than violet. And then if you go even smaller, you get X-rays and gamma rays. So the width, the wavelength, determines the type of light. 83, we're going to reflect on what we've learned by completing a diagram here. It shows two different light sources, light source 1, light source 2, shining on the same material, this cylinder. So the first question, are the two sources of light the same? How do we know? So here we've got light source 1, light source 2. Are they the same? The answer here is no, they are not the same. We don't know what light source 2 is. It could be any of these waves, but we know it's not the same as light source 1 because light source 1 causes the material to get warm, and light source 2 causes the material to be damaged. So if there are different effects on this object, that means the light has to be different. If they were the same, both would be warm or both would be damaged. B, for light source 2, we have 3 options for the wavelength. Which of the 3 matches the wavelength for light source 1? So light source 1 we see here. Which one of these matches? Okay, pretty much everyone says C. It's pretty obvious. This, if you drug it up here, would just overlap that wave perfectly. Now, the tricky thing is we're just looking at the wavelength. And actually, B here also matches light source 1. If we followed the peaks up, this peak matches this peak. The middle peak going straight up matches the middle peak. The last one going straight up also matches this peak. So B has the same wavelength as C, and both of these have the same wavelength as light source 1. So B and C both match light source 1. C, for light source 2, we have 3 options to the wavelength. Which one of the options has a different wavelength? So we just said that B and C have the same wavelength. So the one that's different is A. This wavelength is much thinner, it's more compressed, the waves are closer together. D, which of the waveforms is most likely the correct one for light source 2? So we said B has the same wavelength as light source 1. C has the same wavelength as light source 1. So if light source 2 was B or C, we would expect the effect to be the same as light source 1 because it would be the same exact light. Because we know the effect is different, it causes damage instead of warmth, the wave has to be different. Going back up here to our key concept, different types of light have different wavelengths. So because we know it has to be a different kind of light, it has to be a different wavelength, and the only one that has a different wavelength is A.